Large holes in the Antarctic sea ice remain a mystery to scientists despite their discovery over 4 decades ago. These vast areas of unfrozen water, often referred to as polynias, which is a Russian term for natural ice hole, were first spotted in Antarctica's Weddell Sea during the 1970s. They can grow as large as New Zealand and last anywhere between 3 weeks to 3 years. To better understand the phenomenon, oceanographers from the University of Washington, led by Ethan Campbell, have analyzed decades of data on polynia development, specifically data from two holes that formed in 2016 and 2017. The team has recently published their research in the journal Nature. I'm Matthew Hall, and I got in touch with PhD student Ethan Campbell to find out how exactly polynias are forming.
We realize that there are a combination of factors that have to occur for one of these polynias to open up. And to understand that, it helps to think about the system as a whole. So there's the ocean, and on top of it, there's this floating layer of sea ice. And on top of the sea ice, there's the atmosphere, and all three parts of the system are interacting with each other. Changes in one create changes in the other. And what we see is that the ocean was unusually salty. Specifically, the surface ocean was saltier than usual. So why do we care about that? Well, when the surface ocean is saltier, it means that the barrier to mixing between the surface and the deep ocean is a lot weaker because saltier water is heavier. Unlike a film of oil on top of water, it's not as strong of a barrier, so it's easier to mix between those two layers. And when you have mixing, you release a lot of deep ocean heat, and that heat can come up and melt ice, forming one of these giant holes in the sea ice. And the other factor is that the atmosphere is important. There are these large storms that appear every winter, and a particularly large storm coincided with the opening of both polynias in 2016 and 2017. The reason why that's important is that storms cause a lot of mixing as well. They mix up saltier, warmer water from below, and they kickstart that larger, deeper vertical circulation.
How did you and your team go about collecting the data that was used to form the correlation between these three events you just mentioned?
We went at it in the only way that we were able to, which was to use autonomous or robotic observations. It's very difficult to get to this region by ships for humans in the middle of winter. It's the dead of polar night, so you can't see. It's freezing cold. It's incredibly stormy, as I mentioned. So it's a dangerous place for humans to go, but thankfully I've been involved in this project. It's called the Southern Ocean Carbon and Climate Observations and Modeling Project, or SOCOM. And it's a large initiative to put 200 of these robotic floats into the ocean. And these robotic floats, they drift around about a mile deep collecting measurements. And we, in fact, had two of them in the Weddell Sea where this polynia opened. And that was just pure luck. They collected these valuable measurements of temperature and salinity and oxygen and all of these other variables that tell us about what's happening in the ocean.
Now, for the people listening at home, what are some of the potential ways that these Antarctic ice holes could affect them in their lives?
I mentioned the floats were giving back data on temperature, and temperature matters because in a polynia, you have all this deep water rushing to the surface, and as it does so, it releases that heat. Now that heat goes into the atmosphere, it affects weather patterns in the Antarctic region, but also potentially elsewhere in the southern hemisphere. And not only heat is released, but also possibly carbon. You have to know that there's a lot of carbon locked up in the deep ocean, stored away for centuries normally, and it's stuck there. But when you have this vertical mixing, this carbon gets to the surface and is vented. At least that's what we think happens. We don't quite have a number on that yet. But if it's true, if this carbon is vented within polynias, that could be a minor or maybe even a major perturbation to the climate system. But in a larger event, you could imagine that quite a bit of carbon would be released. That carbon gets into the atmosphere, and it can cause additional global warming.
Looking into the future for monitoring these holes, what are your ambitions? What do you plan to do with the data that you have?
That's a good question because the future may hold any number of possibilities. We may see more polynias, we may see fewer. No matter what, we're probably not going to be able to predict them before they happen. Thankfully, though, we have this huge gold mine of measurements that were taken in 2016 and 2017 from these events. So for instance, there was a large phytoplankton bloom in the summer after the winter during these polynias occurred. Phytoplankton form the base of the marine food web. They're food for penguins, for other birds, for whales. So when there's a large phytoplankton bloom, naturally we want to understand why that happened. and we think it was probably related to the Plania. So that's definitely going to be the subject of future work.
That was Ethan Campbell from the University of Washington, cracking the case on ice holes from his article published in the journal Nature.